In this lecture, we are going to learn about prime factorization of any number. Okay. The two terms are here: prime factorization or factors. Right? What is prime number? Okay. First of all, we will read what is factor. Suppose let us take a number 4. Right? Now, numbers which can divide 4 are what? 1, 2 and 4. Right? These three numbers can divide this 4. So, these three numbers are called as factors of 4. Right? Take another number. Let us say 10. Okay. 1 can divide 10. 2 can divide 10. 5 can divide 10 and then 10. Right? If you want to know what factors are there, so basic rule is what? Write that number, write 1. 1 is a factor of all the numbers. Right? 1 can divide all the numbers. So 1 is my first factor, and write the number 12 as it is in the last. See, 4 is in the last, 10 is in the last. Right? So 1 and 12, because if you multiply 1 by 12 you will get 12. Since this is my even number, 2 must come. Right? 2, if you divide 12 by 2 you will get 6. So your 6 will come here. Right? In this manner you will never miss any factor. Right? So I have taken 2, so 6 is already there. Now I think 3 also. 3 can divide 12, so we will write 3, and if you divide 12 by 3 you will get 4. So your next number from the last is 4. Now see, you are increasing from here, decreasing from here, and somewhere you will meet. So 3, in between 3 and 4 there is no number. So we have got our complete factors. Right? So 1, 2, 3, 4, 6, 12. Right? These are the factors. So now we can write this 12 as what? 12 as 1 multiplied by 12. Correct? Or we can write it as 2 multiplied by 6, or 3 multiplied by 4. Right? You can write it in any way, but we need to write our numbers in form of prime numbers. Prime factorization is basically writing any number in as a product of prime numbers. This is what? Product. So here first of all we need to understand what is my prime number. Prime numbers are those numbers which have exactly 2 factors. Prime numbers are numbers which have exactly 2 factors. Here 3 factors are there. Here 4 factors, 6 factors. So what are those numbers which has only 2 factors? So 2. It has only 2 factors. 3, only 2 factors. 5, only 2 factors. Right? So except 2 you will get all odd numbers as your prime numbers. Right? Because all for rest even numbers, or whatever other even numbers are there, 2 will also come. See, 1 is there for all the numbers. The number will always be there for all the numbers. Okay, and then if you take even number, 2 will always come. See, 4 was my even number, so 2 is there. 12, 10 was there, 2 is there. 12 for 2. So prime number, there is only one even prime number. Rest all prime numbers are odd. So they are like 7 is a prime number. 9 is not a prime number. Why? Because 9 has 1, 3, and 9 as a factor. So what? How many factors? 3. So prime number, you can say only 2 factors. Exactly 2 factors, right? If you get more than 2 factors, what this number is called? This number is called as composite, right? So 2 factors prime, more than 2 factors composite. What about less than 2 factor? There is only one number, which is 1. So 1 is neither prime nor composite, correct? We cannot say 1 as either a prime or composite. So whenever you are asked to write prime numbers, you will not write 1. 1 is what? Neither prime nor composite. Prime numbers are what? Only 2 factors. Clear about prime numbers, composite numbers? Now we will go on prime factorization. So here we have written 12 as 1 into 12, 2 into 6, 3 into 4. We need to write in such a way that only prime numbers will come. Okay, so we can write this 12 as 1 is not my prime number, so not possible. Now 2 multiplied by 6. 2 is my prime number, but 6 is not a prime number. Can we break 6 into other form? Right. Yeah. So now 2, 2, 3 all are my prime numbers. So this is the correct explanation of 12 in the form of factors, right? And this also 3 into 4, if you write, you can split your 4, so both are same, right? So there is only one way you can write a number in the form of product of prime factors, right? So this is known as my prime factorization, right? Okay, now so the question can be asked as write a number as a product of its prime factors, right? I'll show you how to do it in a simple manner again. Suppose the number is 24. Okay, in books they write it like, if I divide, since this is a even number, we can divide it by 2. So I have split it 24 into 2 into 12, correct? This is my prime number, so I can retain this. This is not my prime number. Again we will split like this, even number, so 2 multiplied by 6. This is my even number, sorry, prime number. That's fine, we can retain it here. 2 multiplied by, both are prime number, so we will stop here and we will write only the prime numbers. So 24 can be written as right. It is similar to if we divide in this manner. See, or last step will be what? So except 1, you need to write all the numbers, right? So this is another way of finding factors or writing any number as a product of prime factors. Clear? Right. So now we have learned how to find HCF by division method. Now we will learn how to find HCF by prime factorization. So let us take two numbers, 12 and say 16, right? Or let us say a bigger number, 24. Okay, what is my HCF. We need to find HCF by prime factorization. We can write 12 as 2 multiplied by 2 multiplied by 3, correct, and 24 right. If you want to write it in the power form, you can write 2 to the power 2 because 2 has come 2 times, and 3 as a power 1. Similarly, you can write this also 2 to the power 3, 3 to the power 1. Okay, I'll tell you how to find LCM also in this way. Right. So HCF is, okay, how many different numbers you are seeing here? I have 2 and I have 3 here. 2 and 3. So 2 and 3 are there. So what we will do? We will write 2 and 3. If any other number would have been there, I would have written that number also, right? And the smallest power, right? What is the smallest power of 3? Both are 1 here, so we will write 1. Here the power is 2, the power is 3. What is smallest power? 2. So we will write, this is my HCF. Okay, so what we do? First step, you find out all the prime factors, then you can write it in the form of powers, and then take all the numbers in the HCF and use the smallest power. So 2 raised to 2 and 3 raised to 1. LCM, what you do? You take the highest power. For 3, again, highest power is 1 and the highest power for 2 is 3. So my HCF is 4 into 3, 12, and my LCM is 8 into 3, 24. Correct? Understood the method? What we have done? First step, we need to find the prime factors of all the numbers. Then you write it in the form of powers, and then write all the numbers in HCF and LCM. And in HCF you can write the smallest powers, and LCM highest powers. Okay, I'll give you another example which will be different from these. Okay, now suppose we have 8 and 9. These are the 2 numbers. So first, correct, and 9. So here we got 2 raised to power 3 and 3 raised to power 2. Now we don't have 3 here and 2 here, but we can write. How? Just take 3 and we can take power as 0. So any number to the power 0 is 1. So it will not change my number or the product. Here also we can do 2 raised to 0, correct? So that all the numbers come in both the product here. Okay, now my HCF. My numbers are 2 and 3. LCM also. My numbers are 2 and 3. Now for HCF we take smallest power. So 2 raised to power 3, 2 raised to power 0. The smallest power is 0. Same for 3 also. Smallest power is 0. Here we will take the highest power, 2 raised to 3, 3 raised to 2. So you will get HCF as 1 multiplied by 1, which is 1, and you will get LCM as this. Okay. So what you do? You bring all the numbers in both the products, all the prime numbers, whatever prime number you have seen. See, a 5 is not there, so we are not bothered about 5, 7. Whatever numbers coming here, it should be in both the products, right? Now you need to observe one thing. This was, suppose this is my x, this is my y, right? These are my two numbers, and this is my HCF, LCM. Okay, so there is one formula which we can derive it here. I am writing that formula, that if you multiply two numbers, you will have HCF. This is my formula, right? That multiply two numbers, multiply HCF and LCM, both should be equal, right? If you remember this, 12 and 24, right? My HCF was 12 and LCM was 24, correct? Again, 12 into 24 is equal to what? Right? So if three things are given, two numbers and HCF, you can find LCM by this formula also. How? LCM will be what? LCM will be x multiplied by y upon HCF. Or if you want to find HCF, if LCM is given, x into y upon LCM. Correct? So if two numbers are given and one HCF or LCM is given, then we don't need to convert it into prime numbers. We can simply use this formula to get it. Okay, and we will take one kind of question which comes like, explain why 7 multiplied by 11 multiplied by 13 plus 13 is a composite number. Okay, I have told you what is composite number. Composite number is a number which has more than two factors, right? And we need to prove it that it is a composite number. So what we can do, see, this is my one term, this is my second term, correct? So if we take out this, write it like 7 into 11 into 13, right? What we can do, we can take 13 common from both the terms, and we can write like 7 into 11 plus 1, correct? 7 and 11 was left here, 13, so 1 is left. Now we can write it like 13 multiplied by 77 plus 1, 78, correct? Now see, 13, so this number, whatever this number was, suppose this number is A, right? Now my number A is written in the form of 13 into 78. This is my even number. Even if it was not even number, you can write 1 here. So how many factors? We can already see 3 factors, right? Now 78 can be further divided into other factors, but we don't need to bother about that. If you can show that the number has more than 2 factors, here we are getting 3, it is a composite number. So we will stop here and we can say that since the number has more than 2 factors, it is composite. Right? So any number you get, you write in the form of factors, show that it is more than 2 factors, and hence you can prove it is